Well, welcome to Introduction to Meteorology. So this week we're going to just really begin to look at what meteorology is or what weather is. Talk a little bit about monitoring the weather. Believe it or not, you all do that every day. So what are some of the basic characteristics of the atmosphere and weather? Well, first off, weather is what is occurring right now. So in other words, if you walk out the door right now, that is the current state of the atmosphere at where you are, right at that moment in time. Now, if somebody else walks out 15 minutes later, that is the weather 15 minutes later. It's completely different, maybe. Maybe a rain shower started up during that time. Maybe the wind changed direction. So, weather is constantly changing, it never stays the same. So, we define weather as what is occurring right now. That's why when you look at a weather map, and you're going to look at a lot of them, they are always at a specific time, because otherwise they're going to be telling the state of the weather at completely different intervals. So we always try to get all the observations of the weather all over the country at exactly the same time. That way we can define weather at that moment in time. Meteorology is just the study of weather, the study of what causes it. Climate is averaged over longer terms. The National Weather Service produces a 30-year climate, which tells you a normal high and normal low for your location. In climatology, more detailed study of climate itself. These are the time zones across the U.S. Believe it or not, the National Weather Service, and not just the Weather Service in the United States, but around the world, always uses Zulu or Greenwich Mean Time. It's universal, it's simple. So in other words, when you look at a weather map that says 12Z, well, there's a 5-hour difference on Eastern Standard Time around where we live. So that 12Z is actually 7 a.m. in the morning here, while over in England it would be noon. Oh yeah, on the West Coast, that's 4 a.m. So, but that exact same time defines the weather, because they're all at the same moment in time as far as the world is concerned. So here's just a couple simple weather maps. No data plotted on them whatsoever, except a fronts and a low. So you'll notice here's a low up over the Great Lakes, warm front to the northeast of it, cold front to the south of it. We're going to learn what causes these, why they are what they are. And here's you have another front out in Nevada itself. One of the things, too, about these lows, low pressure, winds flow counterclockwise. In other words, if you looked at the way the clock hands, if you have clock hands on a clock, move, they go clockwise around it. Well, in low pressure, the winds flow counterclockwise, the opposite direction. Highs flow clockwise. And here you can see that. So the winds flow inward in low pressure and outward in high pressure. And we're going to understand why here later on in this course. When you look at a front, what you are is separating two air masses. If I have a cold front moving through my house, one side of the air on that cold front is much colder than the other side of the air. There's an air mass. An air mass is basically a large quantity of air, and maybe covering a whole half of a continent. And as part of that, it's either going to be cold or warm, it's going to be dry or humid. So air masses form over certain parts of the world. Many air masses in the United States form up over Canada. Well, guess what? Canada's cold and it's dry because there's not much water up there. So those air masses are going to be cold air masses, cold and dry. However, if an air mass forms over the tropics, say down over Bermuda or the Bahamas in that area, well, what's it going to be? It's going to be kind of warm. It's going to be pretty humid too, right? So air masses form in different parts and they move. And where they come together are these fronts. So where a cold front is a cold air mass advancing, a warm front is a warmer air mass advancing. And here you can see Another thing about the weather, they're not just all the weather's at the surface, so it's exactly the same aloft. No, uh, fronts have a slope, and which means there's three dimensions to the weather. So if you were living, we'll put a location right here, for example, and you went up in the sky, at some point you would cross over this cool front and you would be in a warm air mass, actually. Even though it's colder aloft, it would be relatively warmer compared to the air masses around it. So you can see there's a slope to the front, and there's a slope in the warm front or cold front. The slope is less, but they both produce lifting upward the air, causing showers and thunderstorms. Not every front is accompanied by it, but many are. So if you wanted to describe the state of the weather, what would you want to know? If I may be important to you might be the temperature. Maybe figuring out what you're going to wear that day. Maybe how much moisture is in the air. Some days it can be really hot and humid outside, and other days it's kind of warm but very pleasant. And that's because of the humidity in the air, how much moisture we have. Oh, maybe you'd want to know how much precipitation has fallen. I know there's been lots of flooding across the Ohio River Valley this summer. They sure wanted to know how much precipitation was going to fall, to know whether there was going to be more flooding. Air pressure, very important as far as we just looked at low pressures, and that was air pressure, and high pressures. Again, air pressure. The tendency is very important to forecasting the weather. Think about it. If a low pressure is moving towards you, the pressure is going to be dropping, right? So that means the air pressure is falling, and that probably indicates the approach of a low pressure system. Wind direction. And interestingly, we use a where the wind comes from for direction in meteorology. In other words, I want to know, is the wind coming from the west, and that means it's a west wind, or it's from the east and it's an east wind. Sky cover, how cloudy the air is. And the Weather Service issues all kind of hazardous weather statements as well. I love to watch clouds, and we're going to get into what causes clouds later. But just looking at the different types of clouds. Here we have cirrus clouds, basically made up of ice crystals in the atmosphere. Here we have more cumulus type clouds, puffier. These are lower parts of them are mainly water. Higher parts may become more icy. Here's fog. Fog is just a cloud in contact with the ground. Mountain valleys in West Virginia and maybe other areas as well, when you're driving down into that lower spot, many times in the morning, there's fog around. Stratiform clouds, they're just layers of clouds. They're flat. They have a little vertical extent to them, but they'll move in different directions. Why do clouds move in different directions when they're around? Well, they move in different directions because the air, we just saw those fronts are three-dimensional. Well, air moves in all different directions as well. So if the air maybe at the low levels is coming in from the east and maybe at the high levels from the west, you may actually see one set of stratiform clouds moving in from the east and another set higher up, maybe cirrus clouds, moving across from the west. Tells you an idea of what is going on. And cumulus clouds become cumulonimbus clouds when they become a thunderstorm, and they really build up very high. Been a lot of those this summer as well across the area. And here is just what I was talking about, clouds moving in different directions. I wanted to spend just a little time today giving you a little idea also on the weather maps. Here is a current weather map. If you looked at it, here's high pressure up here. H's indicate highs, L's indicate lows. Red indicates a warm front. Notice the semicircles on it. Cold fronts have triangles on them. So you can actually see here, there's a cold front almost into Florida, way down south. And here's a stationary front here, not moving. So these are just what you're looking at on the weather map. You can depict high pressure and you can depict the low pressures. By knowing where they are, you know a little bit about what the wind flow is. So you're going to be analyzing a lot of surface weather maps. So I wanted to look a little bit closer maybe at one. We'll just focus in. This has really stuff here. And these are each what we call station symbols. What they are is the weather conditions plotted at a given point, all at the same time, so that we represent it. So for example, if I go up here in the Missouri, I'm seeing 65 and 65. Well, upper left-hand corner is temperature, lower left-hand corner is dew point or a measure of moisture. So it's very humid out here. And guess what? 1, 2, 3, 4 dots. 4 dots is heavy rain. 2 dots, like over here, would be light rain. So 3 dots is moderate rain, and 1 dot is very, very light rain. You have other things like symbols like fog, which are dashes. Oh yeah, and I want to know where the wind's coming from. We've talked about winds a lot. And here you have your wind direction. You'll see a barb, and it points into the center. That's your direction of your wind. So this would be a northeast wind. Wind's coming out of the northeast. Down here, wind's coming out of the southwest. And finally, pressures. Here is a pressure on a weather map. We take pressures in millibars. So this is 171. Well, if that number is less than 500, I typically add 10 to it. So it's 1017.1 millibars. This would be 1015.1 millibars. If the pressure is above 500, put a 9 in front of it. It would be like 969.1 millibars or something. Finally, just looking up at the 500 millibar, which is a halfway up through the atmosphere. Then now we go from pressures to contours. Contours are a measure of 500 millibar changing height. So it's just a location of the actual 500 millibar surface. Everything's 500 millibar in this map, except the 500 millibar changes height. So this is just a depiction of what you're going to be seeing when you do your weather studies. So hope you got a little bit out of this, and please don't hesitate to ask if you have any questions.